Okay, hello, Mr. Lee here. So today's tutorial is going to be on more Pythagorean theorem practice. We saw some basic examples the other day. Today's going to be a little bit more complex, some multi-step problems, some application. So let's get right into it. This might go through fast. I might go through this fast, but just remember you can pause the video, slow down if you need to. Okay, so this is in the context of isosceles triangles. So isosceles triangles, you have two sides of the triangle are the same. So you see 8 and 8. And then that means the opposite angles are also the same. But for this context, what's really happening is if we go to this top point and cut it straight down the middle, it's going to then cut these two parts equally in half. Okay, so this side length is 6, but I can then argue that this is a side length of 3 and a 3. Okay, that's kind of the nature of these isosceles triangles. So you might be wondering, hey, where does Pythagorean theorem involve in this? Well, we can actually take one right triangle at a time. Right, so that's kind of the application here. You're going to be solving some Pythagorean theorem triangles in the context of bigger problems. So if I isolate this triangle, I'll do my best to draw that. I'm going to have an 8 here. I'm going to have an x here. And then we said that this was half of your bottom side. So half of 6 is going to be 3. So we're going to label that as 3 actually. Okay, so the setup is a little complex, but I think you guys can handle it. Now we're ready to actually solve for x, right? Because we have two sides of the right triangle. We need Pythagorean theorem. So let's start with our Pythagorean theorem. A squared plus b squared equals c squared. Let's label some stuff here. Across the right angle is always your c value, and then a and b are interchangeable. It doesn't matter. Okay, but make sure you don't confuse it with c. So let's keep going here. Let's plug it in. A is the same thing as x. I'll just replace it with x. B is going to be 3. I'm going to square that. And then my c is going to be 8 squared. Okay, so let's see what we can do. This is going to be x squared plus 9 is equal to 864. I'm going to subtract 9 on both sides. I get x squared is equal to 55. Right? So if I square both sides, x squared is equal to 55. That means your single x value should be equal to the square root of 55. Right? Square both sides. I can show you what it looks like. It should be like that. Okay? Square root of 55. So that's going to be option C. Boom. All right, see if we can do one more here. Okay, so we're solving for x again. I'm going to do kind of the same thing. Not all these problems are going to be the same, but hopefully you can apply what I'm showing you here. So let me do the same thing. I'm going to draw this out best I can. So there is a 12 on this side. X is there. And then if I cut this 10 in half, that should be a 5. Right? So let's see what we can do here. So I'm going to erase all this. I'm going to leave the a squared plus b squared equals c squared. And let's do some labeling. So start with the right angle, go across to the opposite side. There's my hypotenuse C. And then it doesn't matter what you choose as A and B. I'll just do the same thing. That's A and that's B. So then let's solve it. 12 squared plus a 5 squared is equal to an x squared. Okay, so again, I'm going through this fast, but you guys can pause if you need. 144 plus 25 equals x squared. That simplifies to 169 equals x squared. If you square root both sides, the square root of 69, 169, I'll actually show you. It's actually going to be 13. Okay, so if you look at that, square root of 169 is equal to 13. So you can easily also say that 13 is equal to x. Okay, nothing more complicated than that. Let's solve for that. Solving for x. Okay, so you might see some more complicated problems, but hopefully you'll be able to apply that. Let's do one example of this one, right triangle side lengths. So what's going on in this one is you're testing right triangles. Okay, if you have a right triangle, that means Pythagorean theorem is always going to be true. Okay, so we're going to test this. If it's not true, it can't be a right triangle. If it is true, it has to be a right triangle. Okay, so this one says choose all that apply. Which side lengths form a right triangle? So let's try 3, 4, and 5. Right. So let's try 3 squared plus 4 squared. Does it actually equal a 5 squared? And the answer is yes. Right. 25 is equal to 25. So this one's good. All right, I'm going to keep going here. Does 7 squared plus 8 squared equals 9 squared? Let's test it. 7 squared plus 8 squared equals 113. Let's see if that equals 9 squared. Definitely not. So we cannot choose that one. Okay. One more. 3, 9, and root 95. Does 3 squared plus a 9 squared equal a root 95 squared? The answer is no, because it's going to be 90, right? But I can show you if you have a root 95 and then you square it, it's going to give you back a 95. So that one's also no.